The Universal Data Modeler is based on the Squirrel SQL client, which is a very capable SQL client for connecting to various relational databases. It is in fact implemented as a plugin for the SQL client, and if you look at the list of loaded plugins, you can see it here. So let's have a look at how we can use this modeler. Let's say we open a database. This one is a PostgreSQL relational database, and normally upon opening a new database we get an SQL editor and an object tree like this. So I'll go and select a few tables from the object tree just to demonstrate the capabilities of the modeler. Here we have, I'll select 3 tables here, and I will add them to the graph. That has the effect of creating a new table graph tab here, and if you click on that we'll see the properties of the 3 tables which we have loaded. Now this particular database has no metadata included. That is to say, there's no foreign key definitions or primary key definitions or anything like that, so it's, it corresponds to the sort of database you might get when having imported CSV files, for example. So now that those 3 tables are loaded, we'll run the modeler by clicking on this button here. And what this will do now is to infer relations between the various columns in the 3 selected tables. There we go, we have the results back, and we can see that we've got a number of new relationships identified. These relations are inferred by the data modeler. They're depicted by these blue lines here. And you can see that they're pretty credible. We have an account number column here, apparently related to an account number column there. Similarly, an ACK number column in another table. And we have another relationship down here, which is probably false positive. It's just arrived at given the type and the values of the various columns discovered in the tables. So to show you another example, this time from a MySQL database, let's open it here. And again we get an empty SQL editor and an object tree. And I'll select just that number of tables to demonstrate again the features of the data modeler. We type a location, a sensor type, and a preference type. So these columns describe the sensors, some physical sensors arranged in a temperature and humidity measuring experiment. Again, I'll add these tables to the graph and click on the new tab here, and we see that here we have some metadata included in the database, in that we have that a sensor has a sensor type, and it also has a location in the physical experiment. That makes sense, of course. So let's run the inference on these tables, and we get a new relationship here, which is an inferred one. That is to say, it's not described in the database metadata. Here it's comes about because we have a column in this table which is the matching type, and the values contained within this table is a subset of the names obtained within that. It's for that reason that we establish an inferred relation there. Now, given that we've got this new relation which is not in the database data, if you look at the SQL tab here, you see that we have a number of additional primary keys discovered by the data modeler. And if we look at the graph again, the inferred relation here, we can add this to the SQL tab. And here we have the MySQL specific SQL code to define the inferred foreign relation in the database.